Okay, so in the previous part of this video, you took some notes over how we do longhand electron configuration. And I'm going to make a couple notes on the paper here and do a few examples. I would encourage you to put these in your notebook, and that way you have them to look back at as you're trying some of these problems on your own. So we learned a little bit about these orbitals, where the electrons are. So previously we learned about Bohr models, okay? And we learned that there's protons and neutrons that are in the nucleus, and then we have these energy levels. And we talked about how that first energy level can have 2 electrons, and then the second energy level can have 8 electrons, and that third energy level can have 8 electrons, okay? So we learned the Bohr model. Within these energy levels or shells, we have orbitals, which are just shapes of an electron cloud where those electrons are located. So the first shape we have is a sphere, which is an s orbital, and that can hold 2 electrons. So if you think of our first energy level, this would be an s, meaning that we have a sphere shape and 2 electrons in it. We know then that fills. The second shape we have is a p, and a p orbital kind of looks like, I think of it like if you took the bottom of a bowling ball and took 2 of them and stuck them together by the necks. That's what a p orbital looks like. And so we're looking at 3D shapes. And a p orbital can hold 6 electrons. Then we have a d orbital, and this is like having 2 p orbitals going different directions, and this can hold 10 electrons. And then we have an f orbital, and it's like the d, but then we have one that kind of comes front to back, and you don't need to worry about these shapes so much. And that one can hold 14 electrons. So if you notice, they go up by 4s, 2, 6, 4, or I'm sorry, 2, 6, 10, 14, okay? So those are the orbitals. So what we do is we fill from lowest to highest, and then they go by energy levels. So we start with the first level. So we can think of this like the first level. This is going to be our second level. So you're going to see that this one just has an S because it only has 2, but this has 8. So it's going to have a 2S because we're in the second energy level. And then it's going to have an S which has 2 electrons, and then the P is going to have the other 6 if we're full. Okay, so how does this work? If you look at the periodic table, I have these sheets for you to use, and you'll be able to use them on tests, but we put the elements into blocks. So we have the S block, okay? Each of these rows indicates energy level. So we have 1S, 2S, 3S, down to 7S. Then we have the P block, that's those 6. So this should actually be that orange color. This is part of S because helium only has 2 electrons. So this is P orbitals. And so that starts at 2, 3, 4, 5, 6. This is the D block elements. They're a little bit different. Even though they're in the 4th row, this is 3D, 4D, 5D, 6D. And then these are the F block. And I don't know if you noticed this, but so you have 57 here and 58 here. So these actually go kind of in between here. Instead of making it really long, we put them down on the bottom. So this goes to here and this goes to here until we finish out the F block. Then it goes to this next element. That's why there's such a big space in their numbers. F block starts at, even though this is in the 6th row, it's actually going to be 5F. I'm sorry. It's going to be, 5F and 6F, okay? So, I'm sorry, I'm incorrect. So we had 1, 2, 3, this starts at 4, 4F, 5F, which I know seems really odd, but that's how this one's done. So I'm going to walk you through a couple of these orbital, these electron configurations, okay? So the first one that we're going to do is chromium. So I'm going to write a CR on my paper. I'm going to find it on here. Chromium, it has atomic number of 24, so that means it has 24 electrons. I always write that out first. And then I'm going to use this tool right here, okay? So what this is going to do is I'm going to fill these as I go. So I fill this, then I fill this one, and so on. And you're going to notice as we get a little bit further down that we have Sometimes we'll have a 4 before a 3, and that's just due to how much energy it takes to move into that orbital. So you don't need to worry, you just follow this step by step. So we know S's can have 2, so we have a 1s2. This is the energy level, this is the orbital, and this is how many electrons are in it, okay? Since that's full, then we go on to the next one, and it's a 2s2. So that's 4 electrons, so we have 20 left, okay? Then we're gonna go to 2p, that has 6, so now we're down to 14 electrons left. And then we go to 3s2, now we're down to 12, okay? Then we're gonna go to the next one, which is 3p6. All right, now we've got 6 left, 4s2, got 4 left. And then the next one is 3D, and we only have 4 left to fill even though it can take 10. If I add up all of these exponents, it should add up to 24, so I can double check. All right, let's try one more. We're gonna try sulfur. So we're gonna put an S here. I'm gonna go back to my periodic table and find sulfur. Sulfur is right here, has 16 electrons. So 1s2, 2s2, that's 4, 2p6, so 6, 7, 8, 9, 10, so I've got 6 left. Then I have 3s2, and I've got 4 left. And then I have 3p, and we're gonna do a 4. Okay, the other cool thing is we can also double check these on the table. So we know that chromium was 1s2 all the way to 3d4. If I look at this, I'm going to try to back out a little bit so you can see the whole thing. Okay. I have, if we look at it, there's our 1s2, 2s2, 2p6, 3s2, and then 3p6. Then we're at 4s2, and then 1, 2, 3, 4 into that D block. And if we look back, 3d4, which makes sense, 3d4. Okay, so we can use this to help us double check as well. And we're going to use this for some shortened versions that we will do on Monday. All right. If you want to try your examples, if you run into any problems, please ask. I'd be happy to go through this, do a couple with you. And the answer key is also on Schoology. Thank you.